All right, in geometry, we've been talking a lot about how you're getting ready to start doing proofs. You're getting ready to be lawyers, if you will. So before we get into using different laws, I want to make sure you guys know what they are. So here is a concept list of all of the basically choices that we're going to try to use these in these examples to see if we can prove that whatever in each case is happening based on these laws, these properties. So this is your choice board. Let's go ahead and look at number one. If A equals B, then A plus C equals C plus B. So what they're doing there is they're adding C to both sides. So if they're adding C to both sides, this one is an example of the addition property of equality. So I'm going to abbreviate addition property. Actually, of equality is on almost all of these, so we'll just assume it's of equality, but addition property is fine. Okay, number two, if A equals B and C equals 0, then A over C equals B over C. Oh, sorry, if A equals B and C cannot, that little symbol means cannot equal 0. Because you couldn't have a 0 as a denominator. So if it's some other number but cannot equal 0, then A divided by C equals B divided by C. So again, what we're doing on both sides is we are dividing. So that would be division property. On number three, 12.5 equals 12.5. This is an interesting one that you will use a lot. So please know that if it says one thing exactly equals the other thing, that is called a reflexive property. It's almost like when you're looking in the mirror and you see yourself like a reflection, but it's reflexive. So if it's the same exact thing equals the same exact thing, it's called reflexive property. Number four, if A equals B and B equals C, then A equals C. This sounds a lot like the law of syllogism we just did, and this one is called the transitive property. If you've ever heard of a person being transitive, that means they move around a lot. And what happened with this is it moved. It went from A to B, B to C, therefore A to C. Transitive is the law of syllogism, but we just aren't saying laws right now, we're saying properties. So the law of syllogism is called transitive property when you're identifying it as a property. All right, number five, if A equals B, then B equals A. This one is exactly like what it sounds like you're drawing a line and this reflects over this and it is symmetrical. So this one is an example of the symmetric property. So anything that opens back up, kind of like the butterfly that you probably did in elementary school that you then had to draw the other side of. So it's symmetrical. Number six, looks like on both sides, okay, if A equals B, then A times C equals B times C. It looks like they're multiplying by C on both sides, so this would be a multiplication property of equality. Number seven, I hope looks familiar through all of your algebra work. 3 times the quantity 12 minus 4 is the same thing as 3 times 12 minus 3 times 4. So that should look familiar. It is the distributive property. Number 8, if A equals B, then A minus C equals B minus C. So they're subtracting C on both sides. That would be the subtraction property of equality. And then number 9, A equals negative 4. 6A plus 2 equals 6 times negative 4 plus 2. What we did was we took what A was, which is negative 4, and we substituted it in for A. So this is called the substitution property. Okay, you may reference this sheet during all of your work today. I would need to, especially because reflexive is new. Transitive is that law of syllogism, but it's new. Symmetric is new, even though it's an obvious one. And I think the other ones you should be able to, maybe substitution. The other ones you maybe would be able to get just based on common sense. Okay, let's go to the next page and try some of these. So if the first statement is given, so that just means it's given to us, that we start there, so it's already given. We're going to write what all of these steps happening are doing. And I know it's simple. You guys are like, I just want to solve it. I just want to get to x equals 12. But because you're practicing being lawyers, you need to prove why each step is what it is. So using the laws. So what they did to get here is they combined these two. So this would be, justify each step. So we're justifying each step. They're not all the laws. So to justify that step, we just combined like terms. So we combined like terms. Next, it looks like they got rid of the plus 12 on each side. They subtracted 12, so we'll say this is the subtraction property. Then it looks like they divided both sides by 2.25. No, actually, it looks like they made it from 2.25 to 225. So first, they actually chose to multiply by 100 on both sides. So this is going to be multiplication property. All right, and then last, then they divided. So this is division property. Okay, and I didn't really write property on any of these, but I would accept all of these as answers on anything else. So let's try number 2. It was given that the measure of angle ABC equals 80 degrees. And so what they did was they told us with angle addition postulate that the measure of angle ABD plus the measure of angle DBC equals the big measure of angle ABC, which is this one. Okay, so they added 2 to make it equal this one. So then they substituted 3x plus 3 for angle ABD, and we're basing it on this picture over here, I'm sorry. ABD was 3x plus 3, so they substituted measure of angle ABD with 3x plus 3, and then they substituted the measure of angle DBC with 6x plus 5, and they substituted the measure of angle ABC with 80, because that's what it told us up here in the given. So that is all using the substitution property. So from there, how did they get to 9x plus 8 equals 80? Looks to me like they combined like terms, and they used, they combined like terms. To me, it just looks like they combined 3x and 6x to get 9x. They combined 3 and 5 to get 8. So we're just going to say combined like terms. Next step down, they subtracted 8 from both sides, so subtraction property. And last step, they divided 9 by both sides, so that would be division property. All right, division property of equality. Let's check out number 3. Number 3 says KL, and if it doesn't say anything with it, that means the length of KL, the measure of KL, so from K to L equals 3 of the lengths of PM. So PM, PM, and PM would equal the same measure as KL. Okay, so then they substituted. They made KL equal to 5x because KL equals 5x. And then they did 3, stayed 3, but PM became 2x minus 4 because PM is 2x minus 4. Okay, the next step down, it looks like they distributed to get 6x minus 12, so this is distributive property. Then they subtracted 6x from both sides, so subtraction property. And then lastly, they divided by -1 on both sides, so that was division property. All right, in number 4, they have given to us that xy equals exactly yz. So this side is exactly the same length as this side. I would go ahead and mark it up with those little hash marks. That's just to remind you that that side is equal to that side. Okay, and then they substituted it. So 8m plus 5 equals 6m plus 17. Okay. Next, what did they do? It looks to me like they subtracted 6m on both sides, so subtraction. then they, I think, subtracted again. Looks like subtracted again. And then last step, they divided. All right. This is just practice naming the property. So on number 5, XY is congruent, segment XY is congruent to segment TZ, and segment TZ is congruent to segment XY. So all they did is kind of flip-flop those. That would be symmetric. Symmetry, symmetric property. Number 6, you can tell they have distributed, distributive property. Number 7, it looks like they first combined like terms, and that's all I can really see, so we'll just put combined like terms. And then number 8, they have angle A is congruent to angle B, and angle B is congruent to angle C. Angle A is congruent to angle C. So that would be like law of syllogism, but our property is actually called transitive property. All right, let's look at the last page. So in our last page, we are looking at more actual 2-column proof. So this is where we're going to start leaving our just laws and now start writing them in actual 2-column proof form. So when you have a 2-column proof, you are always given something and you're always trying to prove something. And your proof is always the very last step. So after all these steps, you can see that x equals 28, and that's what we're trying to prove. To begin with, you have to write what's given. So what is given is angle QW2T and angle TWX are complementary. So what did they write on number 1? Angle QWT and angle TWX are complementary. That reason is because it was given to us. They always state the given first, and the reason is just because it was given. Okay, the measure. So now we're not talking about just the angle, we're talking about the numbers, the measure of angle QWT and the measure, plus the measure of TWX equals 90 degrees. And by the way, there's a picture that goes along with this, so I hope you guys are looking at that too. They're saying that the measure of this angle plus the measure of this angle equals 90 degrees. So the reason that is true is because that's the definition of complementary angles. We know that they're complementary because it was given. And for 2 angles to add up to 90, that is actually the definition of complementary angles. So, and I abbreviated that, complementary angles. So anytime it says that something is complementary and then down here it says they add up to 90, that is by definition of complementary angles. Okay, then what did they do? They took this and changed it to 2x plus x, and they took this and changed it to x plus 6. Oh, sorry, just kidding. They changed QWT to 2x, and they changed TWX to x plus 6. So what have they done here? They have substituted. So for this reason, it is substitution. I don't want it to look like subtraction. Substitution. Okay, and then the next step, they combine their like terms. So we're just going to write they combine like terms. And then last, or second to last, they have subtracted 6 on both sides, so that's subtraction. And then very last, they got x equals 28, and that is by division. Okay, you have completed a 2-column proof. Let's try one more based on this picture. What we know, because it's given, is that E is the midpoint. So if you know that E is the midpoint, by definition, that means it's the center of this and this. So that means it's in the dead center middle. So that means these 2 sides would be equal to each other. We're trying to prove that D to E equals 23. So from D to E, we're trying to prove that that equals 23. All right, so let's start in. E is the midpoint of DE. And what you notice is that was exactly what was given to us. So our definition's reason, our statement's reason is given. Okay, and then they filled in some of these opposite on the reasons and then left us with the statement. Definition of midpoint. So if it tells us that E is in the middle, then by definition of midpoint, what that means is if this is the midpoint, then what must it mean about DE and EF? I hope in your head you're saying DE has to equal EF. So by definition of midpoint, DE equals EF. All right. Then they have taken DE and instead called it 6x plus 5. And they've taken EF and instead called it 8x minus 1. That would be by substitution. So they have substituted the numbers in for the letters. All right, next they moved on to, it looks like subtracting 2x from each side. So that would be subtraction. And then by addition, what did they do to add? They probably added 1 to both sides. So this would be left with, well, if they added 1 to both sides, that would be 6 equals 2x because they've already added 1 to both sides. Okay, and then they went ahead and divided. So let's go ahead and divide by 2 on both sides. That would leave x equal to 3. And then they're giving us more information. So now they're saying DE equals 6x plus 5. And the reason we know that that was given is because up here it says DE equals 6x plus 5. So DE equals 6x plus 5, that was given. What about DE equals 6 times 3 plus 5? If we knew up here that x equaled 3, then when they stuck 3 in here for x, that is called substituting it. So this would be substitution. We're substituting a number for a letter, for a variable. And then last, after we went ahead and multiplied those and added 5, we get 23. So you can put multiply and add, or if you want to just call it all together one thing, I'm just going to say simplify. Okay, you can put multiplication and addition if you want to write out multiplication and addition. Or if you know it's 2 steps in one that are both addition, multiplication, that are both just simple mathematical steps, you can just say simplify. All right, very last one. Let's check it out. We're going to write a 2-column proof. I know we're out of room, but let's go ahead and just try. I promise there aren't very many steps on this one, so you'll have to write small, but not that small. We're going to write a 2-column proof for this problem. We're going to put statements on one side, and we're going to put reasons on the other side. Okay, just like we mentioned before, our first statement is always the given. So let's go ahead and write what they gave us. They say that the measure of angle PMN equals the measure of angle RBC. So let's just rewrite that. Measure of angle PMN equals the measure of angle RBC. And the reason is because it was given to us. We know that much because it says so. It was given. What we're trying to prove is that the measure of ABR plus the measure of PMN would equal the measure of ABC altogether. So where would we need to go next? Next, I believe that we would want to go ahead and add. Let's go ahead next and add ABR plus PMN. No, just kidding. ABR plus RBC to prove that it first equals this whole thing. So let's write that out. Let's do, first of all, we want to say the measure of angle ABR plus the measure of angle RBC equals, I ran out of room right there, but that's okay, the measure of angle ABC. And all we did there was we did the angle addition postulate. So angle addition postulate. And remember what the angle addition postulate says is that these two angles added together equal the big angle that makes it up. So ABR plus RBC equals ABC. So it's the big one. All we're talking about is this set of angles on the left. Okay, and now let's go ahead and flip-flop over to grabbing this and plugging it in for here instead. So on our last step, let's go ahead and write what we're trying to prove because we're already there. The measure of angle ABR, and I'm just taking this directly from what we're trying to prove up here, plus the measure of angle PMN equals the measure of angle ABC. And what did we do? We took some of these numbers. We took ABR and left it ABR, but we took RBC and flipped it for for PMN. We replaced it. We substituted it. I'm giving it away now. And then it equals angle ABC. So we substituted this one in for this one in order to do our proof. So all we did was we used the substitution property. And you are done because we started with our given, we ended with exactly what it wants us to prove, and it only took one step, which was by substitution.